here we are trying to solve for x. Typically, what we'd do is we would factor and use the zero product property to solve the two different binomials. The only problem is there are no factors of 5 that add up to 8, so this problem is unfactorable. So what we need to do is we need to add something to make it factorable. So what could work is maybe I add 10, because maybe if I add 10 to both sides, now it's x squared, 8x, and 15, and this is factorable. So this is factorable, but factoring only works to solve when it equals 0, and I equal 10. So that looked like a good idea, but doesn't seem like that's going to work, so let me undo that. Adding 10 doesn't seem to help me. If only there was a way that I could make it so I didn't have to use the zero product property. And that's where we get this idea of the square. We're going to complete the square. We're going to change 5 into 16. And here's the reason why. If I look at 8, I can split up 8 to be 4x and 4x. And I could get that by taking x plus 4 and x plus 4. That would give me x squared. It would give me my 4x and my 4x to be 8x. And then 4 times 4 would be 16. So if I could turn that 5 into a 16, I could have two binomials that are exactly the same. So that's what I'm going to do. I'm going to change my 5 into 16. So I'm going to add 11 to both sides. Okay, that gives me x squared plus 8x plus 16 equals 11. Now, because 16 is 4 squared and 8 is half of 4, I get my two factors to be x plus 4 and x plus 4. Now, you may realize, Mr. Boettcher, you're having the same problem. You're trying to use factoring to solve. You're trying to use the zero product property, but your problem doesn't equal 0. Well, that's not a problem anymore because now my two factors are exactly the same. So because they're exactly the same, they can be thought of as something squared. And so that means I can take the square root of both sides. I can take the square root of my x plus 4 squared, and I can take the square root of 11. What I get is x plus 4 is all that's left on the one side. And that's going to be, excuse me, it's going to be equal to this plus or minus the square root of 11. So if I subtract 4 from both sides, I'm able to find out what x is. And I could find what that number is, but for now I know that x is alone and x has some solution. So this is a long and involved process, and what it's called is completing the square. So let's look at what we did. First, we realized that we needed to have a perfect square binomial. So we looked at 8, and we took 8 divided by 2, which equals 4. And so I knew I was going to have a 4 and a 4. And so then I needed to add 11 because I wanted this to be 4 squared. I wanted this to be 16. So by adding 11 to get 16, that meant I had my 4 and my 4. And because they were exactly the same two binomials, x plus 4 and x plus 4, I knew it was x plus 4 squared. You should eventually see that this is the biggest part of the problem. The fact that I need to have it be the binomial squared. There would be no other way for me to solve this if I couldn't take the square root. The only way I can take the square root is because this is a binomial squared. So what we need to look at is ways that we can complete the square. So I hope that makes some sense to you. I'm going to make one more video. It's going to look at a bunch of different examples of what numbers I can use to complete the square. So good luck.